We're going to be doing your notes for graphing quadratics. That's going to be a parabola, if you remember from the parent functions. We're going to learn two different ways to do that today. Mostly we're going to do standard form today, and then we'll add an intercept form a little bit later. All right, so what are we needing to do? We need to know something about parabolas where we can give characteristics of it. Okay, so you're going to follow in your workbook that you have on page 31. If you'll just watch, I'll have the page on each one as to where you need to keep it. But if you need to, stop the video. If you ever have to, stop the video and then back it up if you need to watch. Or if you go through the whole thing and you don't feel like you really have it, then go back and watch it without having to write notes. Okay, so the first thing here for axis of symmetry, we're just going to kind of draw this out. So if I had something like either a facing up parabola or a facing down parabola, my axis of symmetry is going to go right through the middle. And those are the only ones we're going to be working with right now. So the axis of symmetry is always going to be x equals and then some number. So that's whatever number goes through that vertex. All right, so we're going to be looking at those today. Standard form of a parabola looks like this. So it would be y equals, or f of x equals, ax squared plus bx plus c. Okay, and then minimum value. So if we have a parabola that's facing up, then obviously it's going to have a minimum. And the minimum is going to be whatever that vertex is. When it says value, it wants basically the y value of that vertex point. Okay, maximum is going to be if we have a facing up parabola. I'm sorry, if a facing down parabola, obviously that's going to be a maximum. And again, they want the y value of that. So this video is just kind of showing you how to get that. I just want you to know what it is that we're looking for. Intercept form is going to be a little different. That's going to be something that's already factored. So I believe they use something like this. And again, we'll be doing that one, but we're just not doing that in this particular video. Okay, so what are we going to do then? We're going to talk about using our transformation. So what this means, we're going to move either right or left, and then K means we're either going to move up and down. So we're going to shift the parabola around and then talk about all of those characteristics. If you notice here in the instructions for the very first page, it says label the vertex and the axis of symmetry, then find the minimum or the maximum value, then describe the domain and range and increasing it and where the function is increasing and decreasing. So we're talking only about parabolas, and this whole chapter is about parabolas only. So there's so many cool things though that deal with parabolas. Okay, and then standard form. So we're going to do both of these right now in this video, and then we're going to notice, okay, it's easy in this using transformations. My vertex is obviously going to be HK. You'll see an example of that in a second. But how in the world do I get that when it's in standard form? So that's a whole nother type. Okay, so we're going to stick to those two today. All right, so for example 1, this will be on page 30. We're just going to use that little portion that's there. So we're just going to look at question A. We're going to use the same instructions we just talked about, but we're going to use that first example they have there. Okay, so the first thing it wants us to do, let's stop on, we're not going to do the graphing yet. First, we're going to label the vertex and the axis of symmetry. So the vertex of this one is going to be, if I'm going to take this original graph, so let's say this original x squared graph like this, something like that, and we're going to move it right 1, so 1, and then we're going to move it up 4. Well, now that whole parabola has moved, and all I'm moving is the vertex. I'm moving it from 0, 0, which is the original place, to the point 1, 4. So the vertex is going to be the point 1, 4. Super duper easy to find because you just look at your left and right, which all of you know now because we took our test. So you should already know the transformations. And so that is a very, very easy one to find. So let's talk about then the axis of symmetry. Let me redraw this because I'm not really liking this. So far we've said that the graph is going to move right 1, up 4, and then if you remember also about this negative, it's going to flip it over the x-axis. Okay, I need to understand that so that I can answer the rest of the questions. So the axis of symmetry is really just going to be grab another color in here. It's going to be a line that goes straight through the vertex. Okay, now that is a vertical line. So since it's a vertical line, and we're just going to call this, well, actually use uppercase. Hold on. We're going to say axis of symmetry. Okay, and that's going to be x equals, get that off of there, it's going to be x equals 1. Why is that? Because the line x equals 1 is a vertical line that goes right through the middle where I could fold that parabola over and it would be the same on both sides. Okay, so that's an example of how to find the vertex and the axis of symmetry with a question like this. Now it says find the minimum or maximum. Now if you look at this graph, obviously this point here where the vertex is going to be a maximum because it's the highest of the graph. If it was flipped the other way, where it was a regular parabola facing up, that would be a minimum. So we're not going to give both. We're going to give one or the other. So in this case, we're going to give the maximum, and the value is the y value of that point. So since that is at 4, we're going to say the maximum value is 4. Okay, so your x value of the vertex helps you with the axis of symmetry. The y value of the vertex helps you with the max or min. All right, so that covers this part. Now describe the domain and range. Now this is old news. You've done this forever. The domain, obviously you can look at, is going to be from negative infinity to positive infinity. The range is going to be from negative infinity up to 4, and it is including 4. Okay, we've already covered that, so I'm not going to go into too much detail. What I do want to talk about, though, is increasing and decreasing. Okay, so now we're looking at, and again, we're stopping it at the vertex because it's increasing somewhere and it's decreasing somewhere. So in this case, we're going to say, all right, there's increasing and there's decreasing. I'm going to get a highlighter here and I'll show you. We're basically just going to trace the graph. So if you think about from here, this is supposed to be a highlighter here. If you think about from here to here, am I going up? Am I increasing? If I trace it from left to right, let's imagine again like we're a little person walking on the graph, and I go from the left of the graph up to that vertex, am I increasing or decreasing? Hopefully you can see that it's increasing because you would be walking up a hill. So the way you're going to call that is just like how you did with the vertex. I'm sorry, just like how you did with domain and range, you're going to do from negative infinity, and then it's going to stop at 1. Okay, that's a parenthesis. To 1. Also a parenthesis though, because at 1, it's not increasing anymore. When it gets to 1, it's stopped. And then it's going to start decreasing. So if I go back to a highlighter and I get up to the top of that mountain there and I start to walk down, then obviously I'm decreasing. So in that case, we're going to call this from 1 to positive infinity is going to be where my decreasing happens. Okay, so just take a minute if you need to, pause the video, go back over, or you can either back it up, go back over that because you're going to try one on your own in the next page. All right, on this page, I want you to pause the video and I want you to try part B on your own. When you're ready, when you feel like you have it in your work and you want to go check it, then hit play and check your work. Okay, and we're doing the same thing that we did before. All right, let's see how you did. So my vertex in this case is going to be -1, -2. My axis, shoot, I keep doing that. The axis of symmetry is going to be x equals -1. All right, and then the, let's see what was next. The domain. So if I think about this graph here, it's going to be, let's see, -1 down 2. And this one will be facing up. So this time, when I'm answering the max or min, this one's going to be a minimum. And it's going to be at -2. So your minimum value is -2. That's the lowest y value of that graph. Okay, the domain is going to be from, again, negative infinity to positive infinity. The range is going to be from -2 to infinity. And then the increasing, this time it's going to be backwards from the last one. My increasing is going to occur here. So that's from -1 to positive infinity. So the increasing should be -1 to positive infinity. The decreasing will be from negative infinity to -1. If you need to change anything there, go ahead and change it. All right, so standard form. Standard form, back to page 31. Standard form works the same as far as all the characteristics except for the vertex. We have to find the vertex a little bit differently, and it takes a little bit longer. So first, let's talk about some of these things that you already know because we just went through them. First of all, the properties. This is the difference. Okay, this is what a standard form would look like. All right, and then so what happens is, if we already know this part, but if A is positive, that means it's bigger than 0. So if A is positive, then this graph is going to open up. And this just says is if A is negative, then the graph is going to open down. Okay. All right, so that's what this bullet says. The parabola opens up when A is positive. Basically, it opens down when it's negative. And then it talks about your vertical stretch and shrink. That's what the second one is, which again, you already know. This is the part though we need to make sure that you get. Now, when I get ready to find the vertex, I need a formula. And that formula is take the x value. The x value is -b, so that would be this term, over 2 times a, which would be this term. That will give you the x value of the vertex, so whatever you get. Then you would have to take that value and plug it back into the function to get the y value. That's what this part means. So this is basically your x and your y. It says find out what that first number is and then plug it into the function to get the y value. Okay, so a little bit more work here than what we're used to. All right, and then the Y-intercept, which is something we haven't answered yet. The Y-intercept just says plug 0 into the function and tell me where it crosses the x-axis. I'm sorry, where it crosses the y-axis. So we'll plug in x equals 0, and then wherever that happens is just where it might cross that graph. So something like that. Pretty easy. We're going to do an example on the next page. Okay, so here's your first great example. And so we're going to start. We can't do anything on this graph without first finding the vertex. So we're going to start with our -b over 2a. And in this case, b is actually -6. So we're going to look at this as negative of -6 over 2 times a, which is 3. Okay, so we plugged in b and we plugged in a. Negative of -6 is +6. And then 2 times 3 would be also +6, so that gives me 1. And I'll try to be nice to you and give you things that are not fractions. Okay, so now what we've got to do is we found the y value, the x value of 1. We've got to go back now and find the y value. So let me get a different color here and I'll show you what that would look like. We're going to take our original function, but we're going to plug in 1. So that would look like 3 times 1 squared minus 6 times 1 minus 2. And then we're just going to solve this. Now be very careful when you solve this though. You have to remember order of operations and solve 1 squared first, which is 1. 1 times 3 would be 3. And then minus 6 minus 2. All right, so that's going to be pretty easy. 3 minus 6 is -3. -3 minus 2 is -5. All right, so we now have a vertex. Once we have the vertex, we can answer all of those other things. So we're going to go to 1, -5 and put our point. We already know this one's going to open up because it starts with a +3. So the only other thing we need to do then is figure out where it's going to cross the y-axis. And so what we do is we're going to take the function, plug in 0, and it would give us, well, I'll show it to you, but you won't have to do this after a while because you'll see how easy it is. When I plug in 0 here, I get 0 minus 0 minus 2. Well, that's just -2. So I'm going to go to 0, plugged in 0, got out -2, so that's the point 0, -2. I'm going to put my point. Now notice this obviously has to be a parabola, and that point is 1 away from where the vertex would be. So my point that's going to match it, which is why we have an axis of symmetry, is going to be over here. So now I have this function or this graph here that I can give all of my pieces to. So now I can say what the vertex is, which is what you would be asked. The vertex in this case we found to be 1, -5. The axis of symmetry is going to be x equals 1. You do have to have x equals because that is a line, like we said before. The, let's see, max or min. This one's going to have a minimum. So you'll say the minimum value is at -5. The domain is still, as you'll notice, all of these are negative infinity to positive infinity because it's all real numbers. We're not making them go left and right yet. That's coming, but not yet. All right, the range this time is going to be from -5 to infinity. And then let's see the, increasing and decreasing. Okay, the increasing in this case looks like it's going to start at 1. Let me try the highlighter one more time. It's going to go from here to here. So you want to read that on the x-axis. So that's going to go from 1 to positive infinity. So I'm going to go from 1 to infinity. My decreasing is going to be the exact opposite. It will be from negative infinity to positive 1. And that should be everything that you need for all those characteristics.